Welcome to the HistoryNetwork.org podcast. Do like our Facebook page. Just search for The History Network on there, where you can find out all about the other podcasts we produce. Or pop along to the website, where you can find info about them all there as well. And on the website you'll find our store, where you can download whole seasons of archived podcasts for just £2 each. If you have any ideas for podcast subjects you'd like to hear us cover, or indeed if you'd like to have a go at writing a script for us yourself, then just drop us a line, info@thehistorynetwork.org, and don't feel daunted about the thought of writing a script. We are here to help and would love to hear your ideas, so do drop us a line. The HistoryNetwork.org podcast, Season 23, Episode 3, World War I Artillery. It's easy to take for granted how artillery was used in the First World War. Artillery acquired a target, usually out of direct line of sight, and fired. But if the target is out of sight, how do they know it was there? How do they know if the shell had landed in the correct location? So much of the technology we are now familiar with, telephones, airplanes, and even consistent manufacturing quality at the turn of the 20th century, was still in its infancy. Indeed, when it came to artillery, even its use came into question. Was it to destroy or neutralise the enemy? In this episode, we'll explore British artillery in World War I. In many respects, very little had changed when it came to artillery in 1914 than in the days of Waterloo. Yes, the guns were better, they fired shells and not cannonballs, but they were still a direct fire weapon. They were expected to have line of sight to their target. And at this point it's interesting to note that the Germans in 1914 used their artillery to both destroy and neutralise the Allies, neutralising French artillery and destroying fortifications. The difference might be subtle, but it's something, as we'll see, the British would later learn. So we'll start by looking at indirect fire. It had been used during the Russo-Japanese War in 1905. For the first time, modern quick-firing guns were employed in large quantities, often deployed under cover and firing indirectly, despite their design as flat trajectory guns. At the Battle of Nanshan, wave after wave of Japanese troops were stopped by Maxim machine guns, barbed wire, and artillery sighted on the reverse slope of the hill. Yet it was the Japanese and not the Russians who at the start of the war had organised observers to direct fire for hidden batteries. Whilst widely observed by other nations, the lessons had not necessarily been learned by 1914. The French had decided it would be a key tactic for the artillery. In Germany and Britain the discussion still raged as to the worth of indirect fire over direct fire. The experience of the Boer War had convinced the British of the need for the artillery to keep pace with the infantry, a task that was difficult in rough terrain. If the artillery was to keep pace with the infantry, it would not have time to deploy indirect fire, which took much longer to set up and fire. Observers had to be sent forward and communications established, calculations then made. The result was, it was believed, that lightweight, rapid firing guns firing directly at the enemy would be more use in support of the infantry in a highly mobile environment. From late 1914, as both sides settled down into prolonged trench warfare, it was now almost inconceivable that the artillery could continue to fire directly at the enemy without itself coming under counter-battery fire. The new skill for the artilleryman to learn would be target acquisition. How do you know where to fire if you can't see your target? Then, how do you know if you've hit? This problem drove developments in surveying and map-making, aerial reconnaissance, both from balloon and later aeroplane, communications to inform and direct the gunners, and other such techniques as flash spotting and sound ranging, techniques which would help target the position of enemy guns when they fired. It would be field survey units of the Royal Engineers who would be responsible for finding artillery targets. On August 1st, 1914, there were 3 field survey companies, all at home, their troops being employed on work for the Board of Agriculture and Fisheries. By October 1914, a ranging section had joined the solitary map officer who was based in France with the British Expeditionary Force. Into 1915 they expanded and became the 1st Ranging and Survey Section. Initially, indirect fire was achieved by the use of aeroplanes. With wireless not available, they would fly over the target and drop a smoke bomb, registering where was to be hit. A number of observers could then take a bearing on the smoke and triangulate the position, providing the gunners with a target. This method would be superseded by flash spotting. This was the art of targeting the enemy by watching out for their guns firing. A number of observation posts would be built 1,500 to 2,000 yards back from the front line. Drawing from the World War I experience, the 1938 British Flash Spotting Manual states, "A flash spotting post requires a large arc of view. If placed further forward than this, it would be difficult to conceal, and the enemy would be able to disturb the observer with machine gun and rifle fire. Accurate observation can hardly be expected of an observer under such conditions." There would be a series of posts along the front, manned 24 hours a day, 7 days a week. When a flash was spotted, a bearing would be taken by the observer, who would then telephone headquarters. HQ, knowing the outpost's exact location, could plot the sighting on a map. Usually a minimum of 3 bearings would be needed to obtain a fairly accurate fix on enemy artillery. The process is relatively simple and accurate. The observers needed a telephone and were issued with a spotting instrument, which was a telescope mounted on a tripod that could measure angles, something that the Royal Artillery already had in their stores for use with heavy siege batteries. A lighter version would later be produced. The second method employed is that of sound ranging. This method allowed the targeting of enemy guns from the sound they produced when fired. As one might imagine, it's a much more complex process in practice than theory, especially during the First World War. The ranging of the enemy gun takes place once it's fired. The corresponding pressure wave of sound is measured across a number of microphones hidden behind the front lines. The early 20th century microphones are just part of the difficulty. The sound travels at 337.6 meters per second, but this known factor can be affected by weather conditions, wind, temperature, humidity, etc. Considering its complexity, it was a technique that had been toyed with before the outbreak of war. French experiments had been hampered by the quality of the microphones. They were not accurate enough to distinguish between the 3 sounds a gun made: firing, the shell flying through the air, and the shell blast itself. As the war progressed, breakthroughs in microphone technology allowed the accurate pinpointing of sound with the Tucker microphone, developed by a Corporal Tucker who pre-war had worked at Imperial College on the cooling of platinum wire by air current. His microphone was specifically designed to detect guns. To improve accuracy, sound recordings were made onto film. This could then be compared against the other microphones to maximize accuracy. The technique was well developed by the end of the war, allowing a gunner to not only pinpoint the enemy, but be able to distinguish the caliber of the enemy guns. As one can imagine, the technological advances made during the war were huge, but it's one French development at the end of the 19th century that really set the stage for the devastation caused by the artillery. In 1898, the French adopted the Canon de 75 model 1897. This long-barreled field gun brought together a number of technological advances. Self-contained ammunition, with the powder charge in a brass case, which also held the shell. This allowed for faster reloading via a rotating screw breech. Smokeless gunpowder was used, but the key element was the hydro-pneumatic short recoil system. With conventional guns, the barrel was firmly connected to the mount. They consequently jerked backwards when fired and had to be both reloaded afterwards and returned to their initial position and reset. The new type of gun featured a barrel in a cradle which could be slid backwards in the cradle. A brake mechanism elastically absorbed the barrel and returned it to its initial position. The weapon itself remained steady, and it was no longer necessary to reset the weapon after each shot. The rate of fire increased exponentially as a consequence, but so did the required supply of ammunition. At the start of the war, the French had 4,000 of them in service. By the end of the war, 12,000 had been produced. They could fire 15 rounds a minute, or even double that with an experienced crew, firing high explosive or shrapnel up to 5 miles away. Other nations were quick to adopt something similar. The British developed the QF quick-fire 18-pounder as their standard field gun. At the outbreak of the war, the British had 1,225 of these guns, and by 1918 nearly 10,000 had been produced. The artillery, in and of itself, was not going to win the war. It would be the poor bloody infantry, and the artillery needed to find new ways to support their attacks. The artillery barrage was a standard tactic. As the front lines became static, it became easier to mass artillery pieces together. These batteries could then be utilised to combine their firepower into awesome barrages, firing thousands, if not millions, of shells over hours or even days to destroy enemy defences. It soon became apparent that even after days of bombardment, once the firing had stopped, the enemy would rapidly return to their positions after sheltering in deep underground bunkers. The lifting of the barrage was the signal for them to emerge as the expected infantry attack was underway. These infantry attacks would more than likely face almost the same defensive obstacles, such as barbed wire, which would not have been destroyed. Whilst the German trenches would have been damaged, they would remain functional and well defended. To combat this, the creeping barrage was introduced. As the military thinkers saw it, the problem was not so much the lack of destruction, but more that the enemy needed suppressing as the infantry advanced. The tactic was first used whole-scale by the British at the Somme in 1916. The preliminary bombardment lasted 5 days, then the infantry advanced behind a curtain of shell fire which moved forward 50 yards per minute. From the start, problems arose. Protocol dictated that to prevent friendly fire casualties, the artillery was not to land closer than 100 yards to a friendly unit. In places on the front lines, no man's land was less than this, so as the men went over the top, the barrage was of no use in protecting the men, as the Germans would already be out of their shelters and manning their positions. The creeping barrage worked to a schedule. They moved forward irrespective of the performance of the infantry, which may have been held up due to enemy fire or terrain. Once the barrage was too far ahead of the infantry, it became no use at all in aiding their advance. A Sergeant Cook of the Somerset Light Infantry taking part in an attack in 1918, following a creeping barrage, noted, "One of the most extraordinary advertisements of 'Look out, we're coming' I have witnessed in this war, in full view of the enemy. How they must have chuckled with glee." According to Cook, the barrage moved too quickly, leaving the enemy free to open up a devastating machine-gun fire on the target they had been waiting for. Over time, the tactic was refined. At Vimy Ridge, the Canadians followed closely behind a barrage moving at 100 yards a minute. A later refinement, dubbed the fire waltz, called for the barrage to hit a position, then move forward, giving the defenders time to rush back to their positions. The barrage would then creep backwards to catch them. We've alluded to how tactically the use of guns changed during the war. Direct over-the-sight deployment was mainly replaced with indirect fire. That in itself pushed the development of the ability to acquire targets out of sight. As this was the artillery war, counter-battery fire became important, the targeting of the enemy's artillery. German defence doctrine on the Western Front called for pre-designated fire zones for German artillery batteries. In the event of a British or French attack, those batteries would open fire on prearranged points, devastating any assaulting forces. If an infantry attack was going to be successful, it slowly became clear that once the infantry were advancing, the enemy artillery needed to be neutralised to minimise the attacker's casualties. And there is a distinction which needs to be made here between neutralise and destroy. Whilst destruction of the enemy battery would be a boon, the primary goal was to prevent the enemy guns from firing. This could be done in a number of ways: killing the gun crews, killing the horses that made up the ammunition trains, and destroying railway systems that fed shells to the guns. This counter-battery fire would be used to aid an infantry attack, but it would be developed further in 1917. The Battle of Cambrai is famous for the use of the tanks en masse for the first time, but the use of the artillery was also innovative. Up until 1917, attacks would be preceded by a prolonged bombardment to destroy the enemy defences and soften up the defenders. Not only would this not happen at Cambrai, but neither would the artillery register their prospective targets. This was done by an observer correcting range fire, and when on target, the barrage would open up. This gave the enemy ample warning of the intended target. At Cambrai, the guns would open up on the pre-designated targets, negating the need for registration fire. The targets would not be the enemy trenches and their defences, rather the enemy guns, thus preventing them from giving instant defensive fire onto the attackers. For predicted fire to work, positions of the British artillery were pre-prepared and accurately marked upon the map. At the same time, German battery positions were slowly charted by observers. Knowing the positions of the British guns and the German locations to be targeted allowed planners to accurately calculate a fire plan for the forthcoming battle even before the British guns were in place. At the last moment, the artillery pieces were brought forward to their positions. This was to prevent the Germans becoming aware of the British battery positions. On the first day of the battle, this gave tactical surprise to the British and proved to be a huge success. Coupled with the use of tanks for the first time and new infantry tactics, the Hindenburg line was penetrated to a depth of up to 5 miles, and whilst the massive German counterattack recaptured much of the ground, it showed how ideas of artillery use and tactics had changed since 1914. Finally, we'll briefly mention aerial reconnaissance, undoubtedly a topic in its own right, but it came to the fore in World War I with the aeroplane. Whilst few aircraft were available at the outbreak of war, those that were usually pressed into the role of reconnaissance. Fitting planes with cameras allowed photo interpreters the ability to report on enemy positions and defences, but they also provided feedback upon the effects of fire. Almost daily photo reconnaissance by Allied aircraft provided excellent up-to-date information about the deployment of the German artillery and possible intelligence about their intentions. It also facilitated the production of huge numbers of up-to-date and highly accurate military maps for gunnery and other tactical purposes. Artillery came of age during the First World War. 75% of the known casualties were caused by artillery fire. As a measure of its importance in 1914, 20% of the French army were artillerymen. By 1918, this had risen to 38%. This is a huge topic, and we've hardly scratched the surface as we've meandered through some of the problems and solutions that faced the artillery. So hopefully we'll revisit again at some point in the future, zeroing in for a closer look. Do remember to like our Facebook page. Just search for the History Network on there, where you can find out about all the podcasts we produced, or pop along to the website, where you can find info about them all there as well, and you can find our store there, where you can download whole seasons of archive podcasts for just £2 each. And just a reminder that if you have any ideas for podcast subjects you'd like to hear us cover, or indeed if you'd like to have a go at writing a script for us, then just drop us a line, info@thehistorynetwork.org. And don't feel daunted about the thought of writing a script. We are here to help. So just drop us a line and we can take it from there. We would love to hear from you. Thanks again for listening. You've been listening to the historynetwork.org podcast, written by Angus Wallace, read by Nick Barker.